I am Anil Kumar. Welcome to my series on vectors. Let me thank my student Shruti for sharing this excellent question. We need to find perimeter and area of triangle represented by the equations L1, L2, L3. L1 is -1 plus R, 5 minus 1. L2 is 7 minus 10 plus S, 3 minus 8, and L3, the line L3, is 3, 13 plus T, 2, 7. Now these are vector equations of three different lines and they form a triangle. So let me just sketch a rough triangle here. So let's say these are the three lines which form a triangle. Let me call this line as L1. Let's say this is my line L1, this is line L2, and this is L3. Let the point of intersection between L1 and L2 be A, the point of intersection between L1 and L3 be B, and C be the point of intersection between L3 and L2. So the first part of this question will find these points of intersections. Once we have these points, then distance is easy to calculate using the distance formula. Adding the distances will give us the perimeter. So that's the first part, to find perimeter. Now how do we find the area, which is half of base into height? Now this triangle is not a right angle triangle, so we'll use a part of trigonometry. Find this angle theta and then find height with reference to this theta. Base times height divided by 2 will give us area. So that is the strategy to solve this question. I hope the strategy is clear. Now you can actually pause the video, answer the question, and then look into my suggestions. Let us see how to solve it. Now let's find the point of intersection between line 1 and line 2, and we're looking for the point A. Now this is the vector equation, right? All the three are vector equations. You could also write these equations in parametric form. So you can say x1 is equal to -1 plus 5r, and y1 is equal to -1 minus r, correct? Now for the second equation, we could write x2 as equal to 7 plus 3s and y2 as equal to -10 minus 8s. And for the third equation, we could write this in parametric form as 3 plus 2t, and y value is given by 13 plus 7t. Let's number these equations as equation 1, 2, and 3. To find the point of intersection A between line 1 and 2, we'll equate these two x values and y values, find the parameters, and then get the point, right? So let's equate x1 and x2 to find the point of intersection A. So we are finding point of intersection of the line L1 and L2. This point is A for us. Now to find this point, we'll equate x1 as equal to x2. That is to say, -1 plus 5r equals to 7 plus 3s, right? So let's bring these terms together. 5r minus 3s is equal to, taking 1 on this side, is 8. Okay. Now for the y values, we have y values -1 minus r. Okay, let me write -1 minus r is equal to 10 minus 8s. Now bringing this to the right side gives us 8s, or we can say minus r plus 8s is equal to, taking 1 on this side, as minus 9. Now we could use process of elimination or substitution to find the answer. Multiplying this equation by 5 and then adding, we'll get our result. So I'm multiplying this by 5, so we get minus 5r plus 40s equals to minus 45. So what we get here is one equation from x, second one from here. I should have labeled this as 4 and 5. Okay. Now if I add 4 and 5, 5r and minus 5r cancel, and we get here 37s, right? So when you add, we get 37s equals to, when you add 45 to this, you get minus 37, right? So s is equal to minus 1. So that gives you the value of s as equal to minus 1. So if I substitute s equals to minus 1, I can find the value of point A, right? So I'm going to substitute s equals to minus 1 in this particular equation. So what we get here is the value of A, which is, for x it is 7 minus 3, which is 4, and for y, minus 1 will make 8 positive, and we get minus 2. So the coordinates of point A will be 4 minus 2. Correct? So we get coordinates of point A. I'm just trying to squeeze in the solution here, since it is going to take a lot of room, right? So what we did was, we substituted s equals to minus 1 in this second equation. Perfect, to get our solution. So that's what we did. We substituted s equals to minus 1. Perfect. And got our solution. Now, let's find the point of intersection B. To find B, we'll look into L1 and L3. So these two equations, right? So now we have minus 1 plus 5r equals to 3 plus 2t. Now bringing them together, we get 5r minus 2t equals to, taking this here, we get 4. So that is one equation. Let's call this as our equation number 6. The y values will be for 1 and 3. So now we are doing equation 1, line 1, and line 3 to find point B. Okay? That is the idea. So the y values here are minus 1 minus r equals to 13 plus 17. Bringing them together gets us minus r minus 7t equals to 14. Multiplying this by 5, we get minus 5r minus 35t. 5 times 2, 20, that gives us 70, right? So this is our equation number 7. Now, if I add 6 and 7, if I add equation 6 and equation 7, what do I get? 5r and minus 5r cancel. We get minus 37t equal to 74. Or t is equal to 74 over minus 37, which is minus 2. Substituting the value of t as minus 2 in this equation gives us the coordinates, right? So what we get here is the coordinates of point, the x value is 3 plus 2 minus 2, and the y value is 13 plus 7 times minus 2, which is, these are the coordinates of point B, right? So minus 4 from 3 gives you minus 1, and minus 14 also gives us minus 1. So the coordinates of point B are minus 1, minus 1. Perfect. So we get the coordinates of point B as minus 1, minus 1, as calculated here. Now let us find the coordinates of point C. C is the intersection of L2 and L3. So we're looking into these two lines. So let's equate. So the process is exactly similar to what we did. Equating the x values, we get one equation, which is 3s minus 2t equals to, taking 7 here, we get minus 4. The second equation in terms of y for L2 and L3, that means these two equations, minus 10 minus 8s equals to 13 plus 7t. Bringing them together, we get minus 8s minus 7t equals to, taking it here, we get 23. Now, in this particular equation, we need to multiply the first one, let's say by 7, and the second one by 2. So what we will do now is times this by 7 and times this by 2. Is it okay? And rewrite our equation. So when you multiply this by 7, we get 21 s minus 14t equals to minus 28, and this times 2 gives us minus 16s minus 14t equals to 26. Now we have to subtract these equations to get the result. We can cancel out these, right? So when you subtract them, what do you get? We get 7, so this is 37s equals to, so this gets added up, so it is 1441, right? So minus 54. I did a mistake. Multiplying 2 by 23 is 46, not 26, right? So it is 46. And when you subtract, you get minus 74, right? So the value of s is equal to minus 74 over 37, which is minus 2. So now, since we know what s is, which is minus 2, we get the point C. Substituting minus 2 here, we can write the value of point C as, let me show it here. So the x value with minus 2 will be 7 minus 6, right? And the y value with minus 2 will be minus 10. Minus 2 makes it positive 16. So it becomes 1, 6. So the coordinates of point C are 1, 6. Okay? So these are the coordinates of point C. So that is how you would actually get the coordinates of the vertices for your triangle. Perfect. So we have got the vertices of our triangle. The vertices are for A, 4 minus 2. B is minus 1 minus 1. C is 1, 6. Let us calculate the distance, rather the side lengths of the triangle, and find the perimeter. Perfect. So let's do it on a fresh page. So let me redraw the triangle with the vertices which we just calculated. So we have a triangle here, The vertices are A is 4 minus 2, B is minus 1 minus 1, and C is 1 6. To find the perimeter A to C, we can use the distance formula, right? So magnitude of AC is equal to square root of 1 minus 4 whole square plus 6 minus 2, which is 6 plus 2 whole square. And that gives you 5 square plus, let me write here, square root of 3 square plus 8 square, right? So 64 plus 9, which is square root of 73. So A to C is square root of 73. Now let's find A to B. Magnitude of AB, this side length, is square root of, let's say, 4 minus 1, which becomes plus 1 whole square, plus minus 2 minus 1 whole square, which is 5 square, which is 25, plus 3 square, which is 9. So it is square root of 34. Right? So that becomes the side AB, square root of 34. Now let's find BC. BC will be square root of 6 minus 1, which is, I'm taking, okay, let's take 1 minus 1 first. 1 minus 1, which is 2 whole square, plus 6 minus minus 1 whole square. That gives you square root of 2, 1 square is, 2 square is 4, plus 7 square is 49, which is square root of 53. Square root of 53. I've done a mistake here. 4 minus 1 is plus 1. This is minus 2 minus 1. So this becomes positive. So this becomes positive. So it is minus 2 plus 1 is 1 square. So it is not 9 but 1. And so this length is square root of 26. AB is square root of 26. Okay, so that is how you're going to find the side lengths. Now once you know the side lengths, you can say what the perimeter is. So perimeter is equal to sum of all these, which is square root of 73 plus square root of 26 plus square root of 53. And that is equal to square root of 73 plus square root of 26 plus square root of 53 is equal to 20.92. Let's write this as 20.9 units square. Units, right? So this is the length. So the perimeter is 20.9 or 21 units. Okay, so we have found the perimeter. Now, let us see how to find area of this particular triangle. We know the side lengths. We know the equation of the lines. And let's see how to find the area of this scalene triangle. So again, let's redraw the triangle. We know the vertices A, B, and C are 4 minus 2, B is minus 1 minus 1, and C is 1 6. We also found that the sides are square root of 26, square root of 73, and square root of 53. Now to find the area we need to drop a perpendicular from C to AB. Now area is equal to half base, which is, let's say, AB, times, let's say this point is DCD, the altitude, right? So that is the area of this triangle. Now the question is, how do you find CD? To find CD, I should find the angle theta here, the angle A, and then 73 sine theta will give us CD. So that is the whole idea. So let's see how to find this particular angle. To find the angle, we can use dot product, correct? Now, as you remember, these sides which we are talking about, AB was treated as side L1, right? So this is L1. So AB is L1 and L2 is AC. Correct? So we are going to use these two lines to find the angle theta using dot product. The direction of these lines is, so the direction of AB is 5 minus 1. The direction of line AC is 3 minus 8. Correct? So the dot product of these two will give us the angle theta. So the dot product of 5 minus 1 with 3 minus 8 should be equal to the magnitude of this times cos theta, or we can say cos of theta is equal to this dot product divided by its magnitude, which is 5 square plus 1 square square root times 3 square plus 8 square square root. Correct? So that becomes the cosine. We know this length is 26 and 73. Let's do the dot product. So 5 dot 3 is 15 minus 1 and minus 8 gives us plus 8 over square root of 26 times square root of 73. That is cos of theta. So theta is cos inverse of all this. 23 over square root of 26 times square root of 73. So let's calculate this answer. So a shift cos inverse 23 divided by square root of, so within square root 26 times 73 is equal to, we get 58.134. So we get theta equals to 58.134, right? So that is the value of theta. So we have found the angle theta. Now from here we can find CD, right? So what is sine of theta equals to? Sine of theta is opposite side CD over the hypotenuse, which is square root of 73. So CD is equal to square root 73 times sine of angle theta, which is 58.134. Correct? So we already have the angle here. We can say sine of our answer times square root of 73 is equal to 7.256. So that is the length of the altitude. Since we know CD now, we can find the area, correct? So the area is equal to half of AB, which is square root 26, times CD, which is 7.256. So we already have 7.256. We'll divide it by 2 and then multiply by square root of 26 to get our answer, which in decimals is 18.5 units square. So it took time to do the question, but I hope the steps are absolutely clear and you understand the process. So finally, we get area as 18.5 units square. So the idea here is when you are given three different lines, first find the point of intersections. Then definitely calculating side lengths is easy using the distance formula. Now, to find the area, we could use dot product to find the angle between any two lines. Once we find the angle, we can use a bit of trigonometry to find the altitude as we have done here. And that helps to solve such questions. I hope you understand and appreciate the whole process. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Again, thanks a lot to my students for sharing this particular question. Thank you and all the best.